Picture this, November 1st, 2025, a single day that could shake the foundation of everything we believe about the cosmos. The mysterious interstellar object known as 3I Atlas might not just glide through the solar system, it could explode into a phenomenon that rewrites the story of humanity's place in the universe. Imagine a colossal visitor from deep space hurtling faster than anything we've ever recorded, then suddenly awakening. Sensors flare to life and streams of strange probes begin streaking toward Earth. Could this be the ultimate proof we've been waiting for, that we're not alone? Or is it something far more dangerous, an interstellar trap hiding behind a veil of wonder? This isn't a sci-fi fantasy ripped from a blockbuster screenplay. It's happening now, a real-time cosmic drama unfolding through hard data and expert observation. Look away, and you risk missing the revelation that could redefine existence itself. Stay with me. We're about to peel back every astonishing layer of this enigma, one revelation at a time. By the end, you might never look at the night sky the same way again. You'll see beauty, but also possibility, mystery, and maybe a hint of fear. Before we dive in, here's something worth noting. 97% of viewers never subscribe. Let's change that. Hit subscribe if you want to stay ahead of history as it unfolds. Hello, everyone. I'm Michio Kaku, theoretical physicist, futurist, and author of best-selling works like Physics of the Impossible, The Future of Humanity, Quantum Supremacy, and the God Equation. Today, we're venturing into one of the most electrifying astronomical mysteries of our era, an interstellar visitor officially named 3I Atlas. But make no mistake, this isn't some distant speck in the void. It could be a messenger, perhaps even a technological artifact, bearing secrets that could upend everything we think we know. And with November 1st, 2025 only a day away, the excitement is reaching a fever pitch. That moment could determine whether Atlas proves itself an oddly behaving natural object or something engineered, something designed. So let's start at the beginning. On July 1st, 2025, Atlas was officially detected by the Asteroid Terrestrial Impact Last Alert System, a global network of telescopes known simply as ATLAS. These observatories, stationed in Hawaii, Chile, and South Africa, continuously sweep the sky for potential threats, tracking every rock, comet, and fragment that might cross Earth's path. At first, Atlas appeared routine, a faint moving point, cataloged and tagged like thousands before it. But as data streamed in, astronomers froze. The readings didn't make sense. The velocity? A blistering 58 kilometers per second. For comparison, Earth moves around the Sun at a calm 30 kilometers per second, and even Mercury, clinging tightly to the Sun's gravity, races at 48 kilometers per second. Atlas was faster, unnaturally fast, and that's when the alarms began to sound. And yet, there it was, Atlas, discovered far beyond Jupiter's orbit, racing through the void with such incredible force that its trajectory could only mean one thing: it wasn't from here. Its path was hyperbolic, an open curve slicing through the solar system, screaming of interstellar origin. It came from the abyss. And after one fleeting dance with the sun, it would be gone again, cast back into the darkness between the stars. So why does November 1st carry such weight in this unfolding cosmic mystery? Just 2 days earlier, on October 29, 2025, Atlas reached perihelion, its closest encounter with the Sun, at roughly 203 million kilometers, or 1.4 astronomical units, just inside Mars's orbit. There, under a relentless storm of solar radiation measuring 770 watts per square meter, the object was bombarded with energy intense enough to rip apart most comets. Ordinary comets, fragile clumps of ice and dust, would have boiled into chaos under such punishment. In space's vacuum, ice doesn't melt. It sublimates, vanishing straight into gas and leaving behind that ghostly halo and glittering tail we recognize as a comet's signature. Under those conditions, Atlas should have shattered, its fragments vaporizing in a spectacular burst, a dazzling plume visible across the heavens. It should have been beautifully destroyed, but that's not what happened. This is where the mystery deepens. Harvard astrophysicist Avi Loeb, whose bold theories have often challenged the boundaries of our imagination, has proposed a startling alternative. What if Atlas isn't natural at all? What if it's engineered, a machine, an artifact designed, not born? During its closest solar pass, instead of disintegrating, it may have awakened, its systems activating in response to the sun's energy. Perhaps it ignited propulsion, flashed artificial beacons, or even, most astonishingly, released a fleet of miniature probes into the void. Unfortunately, the sun's blinding glare during perihelion masked any direct observation. For now, what truly happened behind that curtain of light remains hidden. But tomorrow, November 1st, the story reopens. As Atlas emerges from behind the sun, this post-perihelion window could become the most critical moment of all. If the object is truly under intelligent control, this would be the phase to maneuver, to adjust its trajectory, or deploy something toward nearby worlds. And the timing is uncanny. On November 3rd, Venus will pass a mere 97 million kilometers away, an ideal alignment for interplanetary operations. In his most recent paper, Loeb drew a chilling parallel, the ancient Trojan horse. Could Atlas be a cosmic deception, masquerading as a harmless comet while concealing technology within? Imagine those probes separating silently, setting their course toward planetary targets, perhaps even Earth, under motives we can only guess at. Scientific, exploratory, or something far less benign? Make no mistake, this isn't wild science fiction. The theory is grounded in a chain of measurable anomalies that set Atlas apart from any interstellar visitor we've ever studied. To understand just how extraordinary it truly is, we need to compare it to the ones that came before. Atlas isn't just another space rock, it's the third confirmed interstellar visitor ever to enter our solar system. That's why it carries the name Three-Eye Atlas. It follows in the legendary footsteps of two earlier cosmic trespassers, Oumuamua, discovered in 2017, and Borisov in 2019. Oumuamua left scientists speechless. It wasn't shaped like any asteroid or comet we'd seen. It was long, slender, like a tumbling cosmic cigar, possibly stretching nearly 400 meters end to end. Stranger still, it showed no glowing coma, no tail of gas or dust. Theories ran wild. Was it a fractured shard from an alien world? A chunk of frozen hydrogen? Or, most controversially, an abandoned light sail, drifting relic of another civilization? Then came Borisov, a more familiar visitor. About a kilometer wide, it behaved exactly how we'd expect a comet to behave, venting gas, forming a tail, and moving predictably. It comforted astronomers, a reminder that not every interstellar guest had to be a mystery. But Atlas rewrites the rules entirely. It's enormous, possibly 5.6 kilometers across, roughly the size of a small mountain. Compared to its predecessors, it's a behemoth. And its velocity? Nearly double that of both Oumuamua and Borisov. That kind of speed suggests one of two things. Either it was flung from its home system with unimaginable force, or something gave it a boost after it left. And then there's its trajectory, a riddle on its own. The first two interstellar objects entered from the northern celestial hemisphere, roughly matching the direction of our solar system's galactic drift. Atlas, however, didn't follow that pattern. It arrived laterally, sliding into the solar system almost perfectly along the ecliptic plane, the same flat disk where every planet orbits the sun, within a razor-thin margin of just 3 degrees. Out of infinite space, it hit that alignment nearly dead on. Coincidence or intention? The deeper astronomers looked, the stranger it became. Its story actually began months earlier with NASA's Transiting Exoplanet Survey Satellite, TESS. On May 7, 2025, TESS picked up Atlas faintly near Jupiter's orbit. Based on its distance, scientists expected a mild 1.5-fold increase in brightness as it drew closer to the sun, completely normal behavior for a cold, reflective object. But instead, Atlas erupted in brilliance, brightening by a factor of 5. That's not a reflection, that's activity. Something inside was changing. Two clues stood out from the data. First, the polarization of its scattered light. Almost every known object, from asteroids to icy comets like Borisov, produces positive polarization. Atlas didn't. It displayed the most intense negative polarization ever recorded, an optical signature so bizarre it implies surface textures or particles utterly unlike anything naturally formed. Second, the timing of its activity. Atlas's coma, the halo of gas and dust that surrounds active comets, appeared far too early, beyond 5 astronomical units from the Sun, in temperatures near minus 200 degrees Celsius. At that distance, comets should be silent, their ices frozen solid, yet Atlas was already awake, releasing gas rich in carbon dioxide at a ratio of 8:1 compared to water vapor. Something about this object doesn't just defy explanation, it mocks it. This wasn't just another cometary oddity, it was an inversion of everything we thought we knew. Most comets are rich in water vapor. Atlas, by contrast, was dominated by carbon dioxide, flipping the standard profile upside down. Carbon dioxide has a far lower sublimation threshold than water ice. It behaves like dry ice on Earth, vanishing instantly into gas the moment it's warmed. That explains why Atlas woke up so early. But it also raises a troubling question. Why was it made of so much CO2 in the first place? Was it formed in a faraway carbon-heavy stellar nursery? Or does this chemical fingerprint hint at something artificial, a system deliberately engineered to sublimate under precise conditions? Then came the real shocker, the metallic mystery. Midsummer spectroscopic data revealed nickel in the coma surrounding Atlas. That alone wasn't strange, but iron, nickel's ever-present cosmic partner, was missing completely. This is unnatural. Across planets, moons, and asteroids, iron and nickel are twins, born together in the furnaces of stars and rarely, if ever, found apart. So what could have separated them here? Some scientists suggested selective vaporization. Perhaps the intense carbon dioxide flux carried away nickel atoms more efficiently, but that theory feels stretched. Such precise separation seems more at home in a laboratory than in the chaotic chemistry of space. Could we be looking at something refined, maybe even manufactured? And then, as if to tease us, everything changed again. In late September, iron signatures suddenly appeared. The nickel-to-iron ratio balanced out, returning to typical cosmic proportions. It was as though Atlas had corrected itself, camouflaging into something more comet-like, as if it didn't want to stand out. A cosmic chameleon, changing form mid-journey. Now, with November 1st just hours away, the stakes couldn't be higher. Atlas is moving away from the Sun, and this is when its true nature could finally reveal itself. If its speed or course suddenly shifts, if its light flickers unnaturally, those would be the fingerprints of control, of an artificial hand at work. If probes were indeed released, this would be their moment to act, to use Venus's gravitational pull on November 3rd as a slingshot, fine-tuning their trajectories deeper into the solar system, perhaps even toward us. Meanwhile, the European Space Agency's JUICE mission, the Jupiter Icy Moons Explorer, is perfectly positioned to observe this historic event. Its array of sensors, high-resolution cameras, spectrometers, and particle detectors could capture phenomena we've never seen before. Metallic fragments that don't fade like dust, inexplicable heat signatures hinting at internal power, or even the faint silhouettes of detached structures drifting free. Imagine for a moment JUICE transmitting an image of a reflective panel glinting against the void, proof not of nature, but of design. At the same time, Loeb's Galileo project has mobilized. This ambitious initiative, 3 advanced observatories combining optical, infrared, and radar technologies, has already begun scanning Earth's skies for unusual intrusions. In the months ahead, these instruments will track anything that behaves unlike known meteors. Fast-moving, non-ballistic, metallic, and deliberate. Their mission is simple yet radical: to gather hard data on unidentified aerial phenomena and potential interstellar artifacts without bias, without denial, and without fear. We stand perhaps at the edge of revelation. The deeper the data dives, the stranger the patterns become. Subtle anomalies around Atlas are beginning to surface, ripples hinting at something more than just a celestial visitor passing through. And now, the next great date on the cosmic calendar looms, December 19th, 2025. Just 6 days before Christmas, Atlas will make its closest approach to Earth, 267 million kilometers away, about twice the distance between Earth and Mars at their closest alignment. If probes truly separate tomorrow, that date could mark their arrival. Harvard's Avi Loeb has jokingly dubbed them Christmas gifts, but these would be no ordinary presents. Imagine payloads containing scientific sensors designed to taste our atmosphere, compact relays meant to open interstellar communication, or silent surveillance units built to observe without being seen. The implications are staggering. If such probes appeared, how would humanity react? Would we extend a hand or raise defenses? Would governments cooperate, or would nations compete to claim the first contact? Behind closed doors, policymakers are already discussing protocols for what might happen if technology of unknown origin suddenly announces itself. But even as debates rage on Earth, another player waits in the outer solar system. By March 16, 2026, Atlas will pass within 54 million kilometers of Jupiter. From its orbit around the gas giant, NASA's Juno spacecraft, exploring Jupiter since 2016, will have a perfect view. Armed with its wide-angle cameras, microwave radiometers, and powerful radio science instruments, Juno could capture the defining evidence: clear images of structure, unusual radio signals, or heat emissions that no natural process can explain. Such data wouldn't just end speculation, it would rewrite physics. Juno might even detect exotic forms of energy, the kind theorists compare to antimatter drives, evidence of technologies far beyond human reach. And the intrigue doesn't stop with scientists. The shockwaves have reached the world's policymakers. A recently leaked white paper, co-authored by Loeb himself, urged governments to prepare for black swan contingencies, rare, civilization-altering events triggered by massive anomalous objects entering the ecliptic plane. The report invoked an ancient warning, the Trojan horse. Troy fell because it mistook deception for gift. Humanity, the document warns, must not make the same mistake. If, in the days ahead, Atlas begins fragmenting, glowing brighter, and behaving like a natural comet, the story may end quietly. But if it stays intact under immense solar stress, if it emits controlled bursts of heat or shifts its path ever so slightly, it will prove something extraordinary. This object is not random. It's built, possibly armored beneath a thin layer of volatile ice, a metallic exoskeleton disguised as stone and dust. And there are whispers, faint reports of microwave emissions repeating at mathematical intervals. Patterns, constants, not noise, but a message. Throughout my decades in theoretical physics, from exploring extra dimensions to mapping quantum worlds, I've wrestled with one haunting question. Are we alone? The Fermi paradox asks why, in a universe so vast and full of potential, no one has ever answered. But perhaps they have. Perhaps civilizations don't send greetings, they send emissaries, machines, silent watchers drifting through space disguised as comets, scanning, studying, learning, never alarming. Maybe Atlas isn't a coincidence at all. Maybe it's one of them. And if that's true, then what happens next isn't just astronomy, it's contact. Skeptics insist there's nothing extraordinary about Atlas. They argue it's just an eccentric comet born in some distant, chemically unusual corner of the galaxy, a statistical oddball, not an alien messenger. But as the data piles up, those oddities begin to look less like coincidence and more like a pattern that refuses to be ignored. Its staggering size, blistering speed, uncanny alignment, extreme polarization, inverted chemical ratios, and bizarre metallic phases, each quirk alone might be explainable. Together, they form a mosaic that strains the limits of natural explanation. At some point, probability gives way to possibility. Even Avi Loeb, often accused of daring speculation, urges restraint in the midst of this interstellar confrontation. Let data, not imagination, decide. Fantasy may fuel headlines, but empirical truth will make history. And now, as the world waits for November 1st, the question looms. Will this date bring another routine observation, or the spark of something unimaginable? Every major observatory on Earth and an armada of orbiting telescopes above it are now locked onto Atlas. Data streams around the globe in real time, networks buzzing with updates. If Atlas so much as twitches off course, brightens unnaturally, or fragments in defiance of physics, it could redefine what it means to be human. This moment stands shoulder to shoulder with the great turning points of science: Copernicus dethroning Earth from the cosmic center, Einstein bending the fabric of space and time, Hubble unveiling a universe of galaxies beyond imagining. Atlas could join that pantheon, catalyzing discoveries that challenge our understanding of astrophysics, biology, even consciousness itself. It could reveal not just new worlds, but new ways of thinking. If probes emerge, they might validate theories of panspermia, life seated across the stars, or uncover technologies that stretch the definition of intelligence itself. To truly grasp what's unfolding, we must look closely at the physics driving this cosmic visitor. Atlas's hyperbolic orbit is the signature of an outsider. Its eccentricity exceeds 1, marking a path not bound to the sun, but flung across infinity, a cosmic traveler immune to solar capture. When first detected near Jupiter, it was racing at 58 kilometers per second, far beyond local orbital speeds. The verdict was clear. Atlas came from beyond the stars. Its size, estimated at up to 5.6 kilometers, was inferred from its brightness. That calculation depends on its albedo, or reflectivity. If Atlas's surface gleams like polished metal, it could be smaller than we think. If it's dark and dusty, it could be even larger. The margin of uncertainty only deepens the mystery. Then comes the geometry, its entrance along the ecliptic plane, the flat, thin disk where every planet orbits. Statistically, random interstellar intruders should come from any direction in space. For Atlas to align within just 3 degrees of that plane is beyond coincidence, a 1 in thousands precision that sparks whispers of intent. And what about its light? The first signs of Atlas came from tests in May 2025, when it unexpectedly brightened by a factor of 5 instead of the predicted 1.5. Such a sudden surge suggests internal energy, perhaps vents opening, crusts cracking, or something even stranger, like contained power sources releasing heat. Some X-ray readings even hint at reactions resembling low-level fusion, though evidence remains inconclusive. Finally, there's the polarization mystery. When sunlight scatters off dust, it usually produces positive polarization, a signature of rough, grainy surfaces. Atlas shows the opposite, strongly negative polarization, the kind you'd expect from smooth or reflective materials. In other words, from mirrors, or from something deliberately designed to look like them. Whatever Atlas turns out to be, it's forcing science to confront its own imagination. If this object is natural, it will be the strangest natural thing we've ever seen. And if it's not, then history is about to begin a new chapter. What we see in Atlas doesn't fit the cometary rulebook, it breaks it. Spectroscopic readings from Hubble and powerful ground-based observatories reveal a startling profile. Carbon dioxide dominates, overwhelming the faint traces of water vapor. Ordinary comets are about 90% water ice, but Atlas has flipped that ratio upside down. Such inversion suggests something truly unusual. Perhaps it was born near a carbon star, rich in CO2, or more provocatively, its composition was designed, synthesized by intention rather than nature. Isotopic analyses may hold the key. They whisper of origins far from any known stellar nursery. Then comes the metallic enigma. Ultraviolet absorption spectra initially flag nickel, yet not iron, a pairing that defies the cosmic norm. These two metals are typically inseparable, forged together in stellar furnaces. Their separation demands either extreme heat, selective chemistry, or something even more deliberate. In September, when iron signatures abruptly appeared, scientists wondered, did we witness a natural unveiling from deeper layers or an orchestrated act of camouflage, a calculated effort to blend in with the debris of the solar system? Now, as Venus draws near on November 3rd, just 97 million kilometers away, the timing couldn't be more suspicious or more perfect. That proximity poses no danger to Earth, yet it offers a priceless opportunity. If probes were ever going to deploy, this is the window, a gravitational slingshot from Venus's orbit that could redirect them toward our planet. Meanwhile, the JUICE mission, the European Space Agency's Jupiter Icy Moons Explorer, has its sensors trained and ready. Its arsenal of particle analyzers, optical spectrometers, and magnetic detectors could dissect Atlas's emissions in exquisite detail. Any anomalies, metallic fragments, artificial radiation, magnetic shielding would tell us instantly that we're not observing a comet at all, but a construction. Simultaneously, Loeb's Galileo project continues its vigilant skywatch. Its AI-driven sensor network scours the atmosphere for fast-moving intruders, objects that aren't meteors, but maneuvering machines. Preliminary scans have already shown transient fast movers skipping through the upper layers of the atmosphere. At Jupiter, Juno's instruments map heat signatures, identifying hot spots, hollows, and radiative flares that could betray power sources. Each passing day adds another thread to a pattern that's becoming impossible to dismiss. In policy circles, the implications have already sparked an emergency doctrine, the black swan paradigm. It calls for preparedness, not panic, for recognition that rare world-altering events like Atlas demand foresight and unity. Think tanks are drafting contingency blueprints, how to detect, interpret, and respond to artifacts. Surveillance frameworks now track for artificiality markers, abnormal thermal blooms, optical pulses, delta V shifts, or shapes consistent with nano or cube-sized probes, sails, or stealthy thrusters. All this builds to one conclusion. Among interstellar visitors, Atlas is an outlier among outliers. Where Oumuamua teased with its strange acceleration and Borisov reassured us with its ordinariness, Atlas stands apart, colossal, calculated, and impossible to dismiss as chance. Statistical models predicted such encounters once every few centuries. Now they're accelerating, a rising curve that scientists like Rubin have already called the surge. Media fascination has followed suit. The so-called Halloween object has inspired documentaries, viral speculations, and feverish debate. But beneath the spectacle lies something deeper. Atlas is changing how humanity sees itself. Whether this visitor proves to be a cosmic anomaly or an emissary from afar, it has reignited a global curiosity, a vigilance that borders on reverence. Perhaps that is its true purpose. As the clock strikes November 1st, every telescope, every sensor, every curious mind turns upward. Will Atlas reveal machinery glinting in the sunlight or dissolve into dust, leaving only questions behind? Either way, the Odyssey endures. The universe has reminded us once again that we do not yet understand it, and maybe, just maybe, it's beginning to answer back.